Now, one of the things that I want you guys to remember, we talked about synthetic division last week sometime. You guys used it, and we called it synthetic substitution. You were substituting in and figuring out what the answer was at the very end. Plug and chug, if you will. Synthetic substitution is the same thing as synthetic division. They mean the same thing. You just didn't know what you were, we just called it something different before.
I really like one and
Well, in this case here, what we're going to do is I'm going to show you guys how to use synthetic substitution, or excuse me, synthetic division for dividing. Now, we're going to use this same thing twice. I'm just going to cross this one out so you don't get freaked out. And we're going to divide x cubed plus 2x squared minus 6x minus 9, and we're going to divide it by x minus 2. X minus 2 is my term. The one rule with synthetic division is that you don't divide by the term, you divide by its 0. So if my term is x minus 2, what's its 0? 2. Good. So this is my term. The 0 then is 2. Okay? Does that make sense?
Yeah.
Your factored term, x minus 2, gives you a 0 of positive 2, if you set it equal. That's where this is coming from. Okay? So here's what you do. You divide with the 0 of the term. You put the 2 out front, make that little box again, pluck out your coefficients, placeholders if needed. 1, 2, negative 6, negative 9. You were reading that stuff, and there's 2 parts to the problem. Okay? So now we use synthetic division.
This is great.
What was our rule?
You carry down 3.
Take down the 1, 2 times that, add it, multiply, add it, multiply, and add it.
Wait, so it's the same thing except for you.
It's just called synthetic division instead of substitution. It's the same thing. Okay? Now, what happens here is that negative 5 value would have been, you know, if x was equal to 2, you get negative 5. That was your ordered pairs you were creating, your x and your f of x. Now, what's different then, we'll do this again with a different term. We're going to do the same thing, but I'm going to divide it with the term of x plus 3. So if x plus 3 is my term, now what's my 0? Negative 3. So we're going to do the same problem with the negative 3 out front. We're going to synthetically divide it here. We have x cubed, oops, 1, 2, negative 6, negative 9. You okay with that? 0. Drop the 1, negative 3, negative 1, 3, negative 3, 9, and 0. No remainder. Basically what you have done here is that you have now told me that when you take x, move this up some, when you take x cubed plus 2x squared minus 6x minus 9, and you divide it by x plus 3, you had, what was it, x squared Oh, we're subtracting, sorry, that is negative. Bring that down. So what you basically are telling me that all of this divided by that equals x squared minus x minus 3. X squared minus x minus 3.
Oh, the first place. Oh, and the last one was the one.
Where's your remainder?
That's crazy.
Now,
So,
one of the things that I want, now, the main thing that happens here is that notice that there is no remainder. Your remainder here is 0. What that tells me is that my term, x plus 3, is a factor of the x cubed plus 2x minus 6x minus 9. So if you think about what we've done in the past, we had 4 terms, x cubed, 2x, 6, minus 6x minus 9. We would try to factor that. We would factor that by grouping because there's 4 terms. You guys would have told me you can't factor it because you don't get GCFs that match up, right? But now you can. You can factor this using synthetic division. What this is telling me is that the factored form of this is x plus 3 times x squared minus x minus 3. And that's the factored form of that polynomial. That's what synthetic division does. Yes, ma'am? I know.
Can we go?
You guys, if you guys know that you're sort of responsible for materials, so you guys know. All right. Yeah. So what happens here is you get synthetic division allows you to factor the unfactorable.
So you can't just reduce that.
Yeah, I know. You have to actually do a little bit of work. I know. Heavy side. Darn it. Okay. That was pretty slick. So let's take a look at that one. What I want to do, we'll do these one at a time. We're going to use synthetic division. We're going to use synthetic division here. I've got x cubed minus 3 or minus 8x plus 3, and I'm going to divide it synthetically by x plus 3.
So it's going to be negative.
Good. I was just about to ask you, if my term is x plus 3, what is my 0? Are we okay with that?
Yeah.
So, ooh, we're missing a spot. What do you do?
Put 0 in there.
Good. Remember placeholders. Chuck a 0 in there. Okay.
That goes on the window.
You don't want us to say plug it in.
So now we put a placeholder in, and we're going to synthetically divide using the 0 of the given term. 1, -3, -3, 9, -1, oops, positive 1, -3, and 0. Dun dun dun.
No,
But then how would you go, like, would you start with it be x squared?
Yes.
And then it would be minus 3x plus 1? Because you just count from going that way to see how many places you go.
What happens here is that, you're right, Christian. Your answer here is when you divide it out, you get x squared minus 3x plus 1. When you start in the 3rd degree, when you divide out, you drop a degree. And it goes in 1 degree less each time. One thing I want you guys to notice though, this only works when you're dividing by a singular degree term. We're not dividing out synthetically with squares. Okay? This isn't going to work with something like this. I can't divide with something like that. Okay? What?
Why not? It's only going to work for...
Because you have to divide out by a 0. Here, I'd have to factor that further to find the 0 to divide by. It's a step later on that we'll get to. Okay. Yeah. Yes, ma'am.
So you only, I'm kind of confused on how like the answer is x squared. Like why is it x cubed?
Because remember, what's happening here is that if I multiply this by x plus 3, I'm going to get x cubed minus 8x plus 3. This is a factored form of that. Every time you use synthetic division, you drop 1 degree. Okay? Yes, ma'am.
So, it's really weird.
Did you have beans for lunch?
Huh?
Did you have beans for lunch?
I didn't even have lunch yet.
Not yet.
I'm going to see the flash.
Okay, so,
The what?
okay. Sorry. So, if like there's more than just like x cubed, if it was like x to the 4th or x to the 5th, then it would start with like
1 degree
this
less.
one it starts like x squared because it's x to the 3rd. So if it was like x to the 4th, it would start with x to the 3rd.
X cubed? Yeah, x, exactly.
So it's just
You always drop a
start
degree.
with 1 down.
you just drop 1 degree. Okay? You always drop 1 degree down. Okay? So do this one. Synthetically divide that, please.
Wait, but the term is negative. The term is x plus 4.
I know, I'm sorry, bad example because it was this. Sorry, I'm just saying some number. I just picked 4. So here. That's all. I was just trying to show you the difference between term, parentheses, number is the value. Well, that was fast.
How do you go?
Fine.
Wait, so is that happening every lunch hour?
Yep. So 30 seconds.
So you drop the
Did you go the other day?
you drop the 1.
The song is there, so called Flash Now.
Sure, victory.
In my yard. Hey, that's what I got.
So when you divide that out, divide that out, you wind up with
X cubed.
this was my 0, so my term is x plus 4 times x cubed minus 4x squared plus 1. Okay? Once again, this is getting you to the point of, well, can you factor things even further, okay? We're factoring using synthetic division. These zeros allow you to do that, okay? It's very, very, very efficient to do.
So that is this.
That would be a factored form, yep. Exactly what you're doing. Yes, sir?
I like this.
So you can use this to factor any
Yeah.
two equations.
Yes. Now, you have to know where to start, though.
Okay.
Today, I'm going to give you guys terms, or I'm going to give you zeros.
Okay.
Tomorrow, you have to figure those out on your own.
So it's like any equation, even though like some of them might be no solution before, but now it's like.
Oh, no, no.
Yes,
What are you
sir.
doing this in the remainder?
You shouldn't get a remainder. If you have remainders, that means it wasn't a factor of it.
Okay.
Okay.
So if we get a remainder, then either we did not wrong or it's unfactorable.
Correct.
Yes.
Now,
I know, like,
huh?
figure that out.
Now, what I want you guys to see here is a little bit different now. Now it says factor the polynomial. Okay? When it says factor the When it says factor the polynomial, that means you're going to factor it as far as you can go. You're going to use synthetic division to start it, but as you get through the process, you're going to go back to some of the old methods that you had as well. So you are given f of negative 3 is 0. That means negative 3 is your 0. If negative 3 is your 0, what's your term? X plus 3. I'd like you to get in the habit, if they give you a term, write the 0. If they give you the 0, write the term. I'd like you to get in the habit of writing both of those out because it becomes more important to be able to do that over the next few days. Okay? So what I want to do is I'm going to use synthetic division to start factoring this problem. Because if you originally looked at this, you had 4 terms, that means you would probably want to group it. If you grouped it, you'd have x squared come out, you get 2x plus 11. Here you factor out a 9, you get a 2x plus 1. You can't do that anymore, can you?
Right.
You would say no solution, and you go to the next problem. Now I say, not so fast. Knowing that negative 3 is a 0, that means that x plus 3 is a factor that can come out. So we need to figure out what it leaves us. So we take out our coefficients. So synthetically divide out. With any luck, you get, let's see, 2, negative 6, 5, negative 15, 3, negative 9, and a 0. You okay with that? All right. So that means that x minus 3 is my 0, My term is x plus 3. Now I have 2x squared plus 5x plus 3. And how do I factor that? Yeah, multiply your tails. 2 times 3. What's 2 times 3?
6.
What times what's 6? You add together, you get 5.
3 and 2.
3 and 2.
And then you add.
What we're doing here is that you're factoring this further.
Oh, that makes sense.
You're finding out all your other zeros and stuff that you can get to, all of your terms. Yes, sir?
So you at the beginning grouped it, so that's how you got the 2x.
No. I didn't group it at the beginning. I had said that normally you would try to group this, but then when we did grouping, you would say that there's no solutions, there's no GCF. By factoring, knowing a 0 to start with, you're able to factor out an x plus 3 out of this to start.
Oh, you got it.
And now you're at a term that you can factor like a trinomial, okay? Now I can factor grouping without too much of a hassle. I have a 2x, I have an x plus 1, take out a 3, an x plus 1. So my 3 terms, guys, my 3 terms of this become x plus 3, x plus 1, and 2x plus 3.
That's amazing.
That's what factoring using the synthetic division allows you to do. If you know a 0 to start, you're whittling out a degree to make it easier to factor. Yes, ma'am?
I know you already said this earlier, but I kind of already forgot. So,
It was that long ago.
what's the difference between synthetic substitution and synthetic division?
Nothing.
So the same thing.
Synthetic, it's the same exact process. The difference between the two is synthetic substitution is a very fast method to get ordered pairs, an x and a y. Okay, the synthetic division is checking to see if you have a 0 to see if you have a factor. You're doing the same process. Okay. What's that?
Like that's synthetic and the other one's like to find the.
Yeah, find the 0. Yeah, find the ordered pair, find the 0. Pretty much it.
Before we were doing synthetic substitution, and now it's.
Correct, but it's the same process. It just means a different thing.
We're doing different things when you're
Yeah, pretty much. Another way you'll see this written is that it'll say something like 1 0 of something is x equals 2. So that means your 0 is what? 2. It says x equals 2. So your 0 is 2. So if it's written where it says that your 0 is 2, what's your term?
X minus.
Good. So 2 is your 0, which means that x minus 2 is your term. Okay. I like to put it next to where I'm synthetically dividing. It kind of keeps things straight so you know which one's what. Going into the other one, do I need to worry about any placeholders? The x cubed minus 2x squared minus 9x plus 18? Roger. Over, under. What's your vector, Victor?
Oh my gosh, it's so close.
You drop your drop. Not a perfect square, it's a difference square. Yeah. So now at this point you know that you have an x minus 2, and then what's this become?
X squared minus 9.
Good. X squared minus 9, which you can factor real quick. You get,
X plus 3, X minus 3.
and you're done. And you just factored it. Yes, ma'am.
Okay. Why is it x squared minus cube? I'm getting x.
You drop the degree. Every time you synthetically divide, you start with cube. Your quotient then becomes an x squared. Okay? You just drop a degree as you go through it. Factoring hopefully now becomes easy. Now, what's going to be different than when I say this?
That just means you go all the way.
Instead
You-
of x minus 2.
You're going to find all of your zeros. So when you factor everything out, yeah, then you write down your zeros. So in this other problem here, we knew that we had a 0 at 2. We used it to factor everything. What were all of my zeros at?
2, negative 3.
So the only thing difference there is that you're finding your zeros at the very end. So do that. Find all of my zeros, please. Sure, this is easy.
We're going
It says like 4.
I might as well check one of them, see how we're doing.
We did it, Mr. Reeves. We did it. I don't see why I can't see it. I did it, Mr. Murphy.
After you synthetically divide, yeah, because then you have a trinomial with the GCF too. Yes, ma'am.
Are we required to write the 4 down because it's already given and it's fine?
Yes, please do, because I'm going to ask that what I want you to get in the habit of doing is writing down your terms and then your zeros below them. I know that you know that's already a 0, and just bring it down with it. Because eventually when we start to graph these, where does this cross the x-axis? 4, 6, and negative 2.
Yeah, it's a triangle.
Oh, the first
Not
one
yet.
is positive.
The first one's positive,
Like
which-
this.
so you know it's got to go.
No way.
It's going to just.
Mr. Murphy, you should retire in 2 years and become a famous rapper.
What? I'm not doing this.
Rocket video producer.
He's on the
Where did that come from?
Yeah. That's exactly what that's exactly what I'm gonna do with my life.
Yes, exactly. You'd be making millions.
I can make it rain.
I call you Murphy Millions. Yes.
I'd sell out many crowds. I can't try. That's bad. All right, 10 is my 0.
Wait, you're gonna do set
2, negative 14, negative 56, negative 40. Oh no, those numbers look so large. I don't know what to do.
It's fine. It's all good.
Woo! I almost broke a sweat, for I have just synthetically divided. So my term was x minus 10. My new one is 2x squared.
6x plus 4.
Now remember, we're finding 0, so let's tack on that equals 0. Now, when I get to that trinomial, your first rule of factoring is what? GCF. Take out. You don't have to, but it makes your life easier because if you take out the 2, when I'm finding zeros and I took out a GCF that was a constant, does that constant have any bearing upon the problem for the zeros? No. There's no bearing upon this problem now with that 2 because I'm finding zeros. So what times what is 2? You add together to get 3.
2, 1. So x plus.
We didn't say the GCF, so we got it wrong.
You should still have gotten the same zeros.
First rule of
It's wrong now. Feels like that's wrong. It's wrong. It is wrong. We can't throw it.
Because your GCF here is just number. You did that. That's why. Remember, you drop the degree as soon as you drop this down. So it started cube, it goes to squared. So this starts cube, this becomes squared, singular, constant. Okay. Now, remember, what's happening here, guys, is that as you go through these, your term, yes?
Can you divide that in the last, can you divide the 10 by 10 as well?
No, because it's telling you the 10 was a 0. The 10 was a 0, so that means your term would be x minus 10. Now, remember what's happening here is that you're getting all these, what do you call them, factors and terms. Now, what's going to happen is, when we get to something like this, where you're dividing it by x squared plus 2x, eventually we'll figure out how do we use that. We don't know what that 0 is, do we? Did you figure out what a 0 is there?
Yeah.
How? How would I find the 0 here? So what's my 0? What's my 0? 0 and negative 2, okay?
Oh, that's so cool.
Now, what's that? Well, I know that 0 is a 0, and I know negative 2 is a 0. Can I synthetically divide all of that out by 0, synthetically divide all that out by negative 2? Yes.
Yeah.
Now, yes, sir?
What if it, like, it's something like that with this exponent and the other x and all that, but you can't factor it
Then you wouldn't be able to use synthetic division. You'd have to use the long division because you might have a remainder.
So like, I don't remember, a few nights ago, there was a couple of them like that where you couldn't factor it anymore, and it was at zeros.
Yeah. Then if you go to the zeros, when you go to the zeros or something like that, you have to go to the quadratic. You might have to use quadratic because there'll be something like that here tonight still where you factor everything out fully to find all of your zeros. Some of your stuff you might have to use the quadratic formula for. Okay. So let me give you a few of these to try for tonight. So this is still as a section.
Understanding all of
Do those, please. Oh, 54. Do those, please. I'm asking. When you read the instructions on these, the first half of them, guys, the first half of them is telling you that something is the 0. Factor it. The second half is they're giving you a term, I believe. Or no, they're giving you the 0. Find all the other zeros. Okay?
So nothing you have.
Nothing you haven't done. You can get some funky roots. That would be my name. The funky roots. It's the imaginary funky root band.
It's not a band if you're a rapper.
Why not? Why can't it be?
They're all rappers.
You're a
Mr.
solo.
Funky Roots. No, Funky Roots Murphy.
Well, there was easy. There was Marky Mark and the Funky Bunch.
Meaning Murphy Murph and the Funky Bunch.
I don't want you guys touring with me. I have to share my millions with you, please. I barely can stand 45 minutes with you.
discovered Martin
You discovered me.